Today's lesson is going to be over rational exponents, which is when you have a fraction with your exponent. But first, let's review our other exponent rules you might already be a little more familiar with. So your product rule, when you're multiplying like terms, they have the same base, you add their exponents. If you raise a power to another power, you multiply your exponents. And this is to demonstrate the power of a product rule. So where your parentheses are is very important. If both a and b are in parentheses raised to that exponent, it applies to both. But if there is no parentheses, then the exponent just applies to what it's touching. Your negative exponent rule, if you have a negative exponent, that means it's on the wrong side of a fraction. So if it was in the numerator, you're going to move it to the denominator to make it positive and vice versa. Zero power, anything to the zero power is 1. Your quotient rule, when you divide like terms, the same base, you subtract their exponents. Power product rule, again, same thing. It applies to both. And then this fractional exponent rule we'll get to later because that's the new thing. So let's do a little practice to evaluate some stuff. This is going to be your product rule. We have that imaginary exponent of 1 here, so I'm going to add my exponents, and this becomes negative 4 to the 4th power. Well, what is negative 4 to the 4th power? It is actually 64. Sorry, it's not 64. I am such a liar. It is 256. This Treadway's brain is lagging a little bit. Pardon me. 256. Okay, on the next one, power rule. This is going to be negative 3 to the 6th power, and 3 to the 6th power is 729. Okay, power of a product rule. Here, that square is going to apply to all of these items, so this is going to become 3 to the 4th. X to the 4th, y squared, and 3 to the 4th is 81. Okay, first let's do this multiplication here. This is going to become m to the 7th over m to the 4. Now I can use my quotient rule, which is where I'm going to subtract my exponents and get m to the 3rd. On 5, let's take care of the product rule in our denominator first of all. That is going to give me 8 to the 8. Now I can use my quotient rule, 8 to the 1, which is just 8. Number 6, this is my zero power rule. Anything to the zero power is just 1. On 7, this is my product rule. I'm going to add my two exponents, and I don't know what y is, so it's just going to stay in my answer. So y plus 6. On 8, again, product rule, I need to add my exponents, but one of them is a fraction. So I'm going to need to convert this into a fraction with the common denominator of 5. So that would be like 25 over 5. So I'm going to have a grand total of 28 over 5. So this is g to the 28 over 5 power. Now 9 and 10 are a little different. If 3 squared times 3 to the x equals 3 to the 10th power, what is x? Well, to figure this out, this would be my product rule, so this would be 3 to the 2 plus x power. If that's equivalent to 3 to the 10th, that means 2 plus x is equal to 10, so x is 8. On 10, similarly, I want to find the value of y. Well, I would have used my quotient rule to get here, so 3 to the y minus 4 would be equivalent to 3 to the 5th. That means y minus 4 is equal to 5, so y is 9. Now that we have reviewed all of those old rules, let's get into some new stuff. When you have fractional exponents, what this really means is you have a radical. So whatever the index is, that number that indicates your radical is a square root, cube root, fourth root, etc. That is the denominator for a fractional or rational exponent. And then if your value is being also raised to another power, that would go in your numerator. So we can use these to go back and forth from radical form to exponent form. First, we're going to go from radical to exponent. So here on example A, this is a square root. Now, when I don't write the index, we are assuming essentially that it is 2 because it's a square root. So this is the same thing as x to the 1/2 power. Again, the index of that radical is in the denominator for your exponent. On B, I have the cube root of 6x. So my exponent is going to be to the 1/3 power. Now this is where I have to be careful because the 6 and the x are both in my radical. So to indicate that this exponent applies to both of them, I need to put it in parentheses. Again, otherwise the exponent is just going to apply to the part it's touching. Okay, on C I have the square root of x to the 5th. So this is going to be x to the 5/2 power, the 2 coming from the index of my radical, the 5 being the exponent. And then D, this is the cube root of 3x to the 4th. Now 3 and x are both in the radical, so I want parentheses to make sure it's very clear they're both part here. And this is going to be to the 4/3 power. Okay, you can also go the other way around. If you have the exponent, you can write it as a radical. This is going to be the cube root of x. This is going to be the square root of x. This is going to be the cube root of 7 and x are both going to be in the parentheses because they're both in, they're both going to be in the radical because of those parentheses. And then you have two options as to where to put that 4. You could put it outside, and I know it applies to everything, or you can put it inside your radical, but again, the 7 and the x need parentheses, so we are making it clear the 4 applies to both parts. Okay, then on D, this is 3x to the 2/3, but I don't have parentheses, so the exponent is only applying to x. So 3 is going to stay outside of your radical, and you're just going to have the cube root of x squared. Okay, on to this next row of examples. Rewrite each expression in simplest exponent form. So I need to convert everything into an exponent first and foremost here. Well, 5th root of 5, that's going to be 5 to the 1/5. Times, this is going to be 5 to the 2/5. Well, now this is my product rule, which means I add my exponents. They're both fractions, but they already have a common denominator. So this is going to be 5 to the 3/5. That one was easy. On B, this is the square root of 7, or 7 to the 1/2, times 5th root of 7 to the 6th power is going to be to the 6/5 power. Again, I need to add my exponents, but they currently don't have a common denominator. So let's rewrite each of these with a denominator of 10 so that I can add them. And 17/10 is going to be my final exponent. Okay, on to C. This is 2 to the 1/3 times 2 to the 5/4. Again, I don't have a common denominator, so I need to make one. And this is going to be 19/12 power. Okay, lastly, 10 to the 5/3 times 10 to the 2/3. Here I do have a common denominator, so I'm going to get the 7/3 power. Okay, now I'm going to go again to simplest radical form. On A, this is going to be the cube root of 64 squared. 64 is a perfect cube. The cube root of 64 is 4. So this becomes 4 squared, which is 16. Okay, on B, I have 6x to the 4/5 power. I don't have parentheses, so this exponent only applies to x. 6 will stay on the outside, and this will be the 5th root of x to the 4th. On C, I have 3,125x to the 6/5 power. Again, my exponent is only going to apply to x here. So this is going to be the 5th root of x to the 6th. I can take out an x to the 5th here. So this would be x and then the 5th root of x. Here, I'm going to take the square root of 25x cubed. Everything goes in the radical because I have those parentheses. 25 is a perfect square, so I can take out 5, and I can actually take out an x as well, with one x left inside my square root. Okay, let's take it up a notch. Let's make things a little more interesting. Find the value of a. Well, a is representing an exponent. So what I'm going to need to do to solve these three is rewrite everything in exponent form and then simplify. So let's start with, I've got x squared to the 1/5 power. Well, that's the same thing as x to the 2/5 when I multiply 2 and 1/5. And then the 5th root of x is x to the 1/5. Product rule, add your exponents. This becomes x to the 3/5, which means a is 3/5. That one wasn't too bad. Let's look at B. In my numerator, I've got the power rule. So this is going to be x to the 4/5 when you multiply. In the denominator, I have x to the 1/6. I'm going to need to subtract those, 4/5 and 1/6. Well, I don't have a common denominator yet, so I'm going to need to make one. That'll be 5, that'll be 24. So this becomes 19 over 30. So this is x to the 19 over 30th power, which means a is 19 over 30. Okay, last one from this set. I'm going to get x to the 2/5 times x to the 3/4. I'm going to add those, but I need a common denominator. Let's go with 20. A little math error here. This should be 8. So I get 23 over 20. So if this is x to the 23 over 20, that means that a is 23 over 20. Okay, negative exponent rule. Again, this just means it's on the wrong side of the fraction, and your key takeaway here is going to be, what does your exponent apply to? What moves? Well, here it's just on the x, so -4 will stay in your numerator, and x squared will be in your denominator. On b, same thing, 3 will stay in the numerator, x will go to the denominator. On c, the whole thing needs to move to the denominator. 1 becomes your numerator. And then again here, the whole thing is going to move because of the parentheses. Okay, I'm going to stop there to make a part 2 because I'm low on time and I want to take these challenge problems nice and slow. So go to part 2 for the last 2 problems.